Thank you. And now it's time for the main characters in this story to take over the stage. So we will start with a startup based in Eindhoven, which focuses on developing free space optic systems as a wireless alternative for backhaul communication. Please welcome Aircision.
Yep. Hey. Wow, nice to be here again. Let me check the mic. Okay. So, we all know connectivity enables prosperity. And I think and there are pretty awesome startups here today, companies that are betting on connectivity to improve people's lives. I'm pretty sure we'll hear awesome pitches. But there is one good thing, is that for good connectivity, we need good infrastructure. And if you look at the current state of infrastructure, there are still, in 2022, 40% of households in the world that do not have access to internet at all. But we tend to think that this is a problem of the underdeveloped economies. But if you look at the maps of the United States and Germany, two of the most powerful and developed countries in the world, we still see the broadband needs are not being met. The colors are a bit weird, but in the United States, you can see that most of the country is still not meeting the broadband needs. Why is this happening? So fiber optics has been around for more than 30 years. It just takes too much time, too much money to roll out, to install, to dig in the ground. It also requires a huge workforce to actually develop it. The alternative is to use wireless technologies. They are easily installed, they can be deployed very quickly, and the current technology being used, radio frequency, has a big trade-off between the bandwidth and the range that it can do. You can have very long distances at very low bit rates, or the other way around. For example, the 5G antennas, very high bandwidth, very short range. The industry is looking into alternatives, and free space photonics, or as Leticia mentioned, free space optics, which is commonly known, is a wireless technology that uses light propagation through the air to transmit data at very high speed over very long distances. This is why it's being used in space for connecting satellites, so huge distances. We were inspired by this, and Aircision developed a system, terrestrial system, that uses free space photonics to connect 2 points. Our system can be deployed in less than 6 hours, so no licenses required, just less than 6 hours. It's already covering 5 kilometers range, and it's transmitting at 10 gigabit per second. I would say even more importantly, when compared to similar wireless technologies, such as radio frequency, it is using 50% less energy consumption. This is per box, per link. So imagine the exponential energy savings on the overall network. Our system is divided in 2 parts. We have what we call the optical heads, which are installed on top of the towers or the buildings, and then we have the baseband unit in the bottom. The optical heads are extremely precise. Imagine transmitting a laser from point A to point B over 5 kilometers, and in point B, we have a receiver which is the size of a coin. It's impressive, huh? It's not only about hitting the receiver, it's about keeping the laser aligned all the time so that we can provide the highest link availability possible. The baseband unit in the bottom is responsible for the speed. It's responsible for transmitting at 10 gigabit per second or a terabit per second, which is where we want to go. We have IP on this, so both on the optical head, so on this very precise alignment system, as well as in the fast deployment, as we have a fast link acquisition system that connect when it's installed in less than 1 hour, the link is up. And we are also partnering with integrated photonics companies, such as Effect Photonics, to actually reach higher and higher bit rates. So go to 100 gigabits per second and beyond. This not only useful for fixed and mobile networks, but we are also exploring use cases for enterprises. So here it's key, the security element, so enterprises can keep all their information in their own private network, but also for defense and temporary connectivity solutions, because our system can be really fast deployed. This is a real case. We are actually working with a company in a country in Africa. I cannot reveal the name, but the main point is you can see that this is a city with over 3 million people, and that orange dot over there is the nearest fiber access point. So the fiber optic cable that comes from the capital to the city. And what they want to do is to use our free space photonic solution to connect a tower on top of a hill. This hill is next to the city. And from there, they provide fixed wireless access to the whole city. We are working today with the two leading telecom operators in Germany for similar use cases. And next year, we'll be rolling out commercial pilots and market launch. The market is huge. Just this weekend, the G7, so some of the biggest countries in the world, gathered, and they said they are going to invest $600 billion in infrastructure, with an emphasis on digital infrastructure connectivity. And let me tell you, we have a fantastic team covering all areas of business, experience in entrepreneurship, finance, technology, high-tech systems, but also diverse. And out of 12 people, we have about 10 nationalities. So a very international team. We are also surrounded by a very strong advisory board, people who used to be C-level executives at the biggest telecom operators in Europe, Qualcomm, Deutsche Telekom, Nokia, Ericsson, and so on. And we are currently raising 3.5 million so that we can industrialize the product you just saw before and conduct market launch next year. Why are we here? Because today we are discussing a project to connect the TUI campus to the high-tech campus. This is about 5-kilometer range. And we involved already a lot of parties, the TUI, the high-tech campus management, and a few other parties here in the region. And we'd like the support of the 5G hub so that we could have temporary, but I would say even a permanent demonstration site for all our clients, so that our clients can come to Eindhoven and see our link working and show the use case. We are doing this because we believe that by improving infrastructure, by providing better telecom infrastructure, we can also improve access to education and information all over the world. We are Aircision, and we are empowering connectivity. Thank you.
Fantastic job. Thank you very much.
Thank you. Obrigado.
Yeah. See? Então eu gostaria de saber. Sorry, and I started speaking Portuguese.
I understand.
That was amazing. It would be so great to host an event in Portuguese. Oh
Next
my
time.
God. Next time. Let's do it. I'd like to know if the jury has any questions for Aircision, and you guys will need a microphone for that, of course. You can ask in Portuguese if you want. Anybody?
I can answer in Portuguese or Spanish or.
I'll try to keep it with English. It's better. I have two questions, but I don't know if I'm allowed. The first one is, can you explain a bit more the 5G link in this one? And the second one is, who are your clients?
Yep.
Who's paying for it?
Yep. Okay, so the first part, 5G. As I mentioned, 5G antennas have quite a short range. So that's about maximum 500 meters if it's on line of sight. That means that they can only cover array 500 meters around the antenna. So if we want to provide very high connectivity and speed to mobile devices on a certain location, we need to provide a very high-speed link to that location. So let's say you want to have 5G service and antenna in an area next to the high-tech campus. I know the high-tech campus has fiber optics, but let's say you want to expand, instead of having only in the 5G hub, if you want 5G on the other side of the lake, we could provide a link between that site, the fiber access point, to the other side of the lake, and then connect it to a 5G antenna where people would have then access to 5G service. Yep, that's the first question. The second one, our clients are telecom operators. So usually they are the challengers, how we call them. So almost every country in the world, you have an incumbent, traditionally a company that was supported by the state, investment, and they have traditionally most of the infrastructure. Over the last 10, 15 years, the markets have started to liberalize in Europe, but also other countries in the world. So new players started to come into these markets. And they need to have infrastructure so that they can provide their services to the end customers. They need to do it fast, they need to do it high speed, and they need to do it in an economic way. That's why our solution is perfect. Not by itself, that's something we always emphasize. Free space photonics is not the only solution, but it's part, together with fiber, together with radio, it's part of the solution to get higher speeds, coverage over the whole network. Okay.
Anybody else?
Yes. Question one, you said that your solution is 50% more efficient, energy efficient than regular mobile communication. Is that on 4G related and 5G networks?
Yes. So what we did is technology being used to it's similar to our solution. It's called the E-band. It's a radio frequency. They use between 60 and 80 gigahertz band, and it can provide 10 gigabit per second over around 2 kilometers, right? 2.5 kilometers. If they want to get longer distances, then they drop the bit rates. So we use that as a comparison. So even if we use E-band, in order to cover 5 kilometers, you need one tower here, you need one tower after 2.5 kilometers, you need one tower 2.5 kilometers, so a total of 4 devices. So if you compare 4 devices with using only 2 from our solution over 5 kilometers, that's already 50% gain. Even if we use the same power consumption. But we use less. That's one of the benefits of using optics. So overall, if we compare a solution of installing and using E-band to cover, let's say, a city with 3.5 million people, then the benefits are exponential.
Maybe the obvious question, you have an optical signal. How sensitive is that to snow, rain, anything that gets in between?
Yeah, that's a great question. That has always been, let's say, the challenge of free space photonics. But now we are in a different point. We are in a point where we want to connect the world at very high speed. And what's crucial and what we hear from the telecom operators themselves is they want to provide most of the time very high bandwidth. And in cases of snow or fog, which block our signal in some cases, so if it's very thick fog, then it blocks, they have alternatives. They have radio frequency at very lower bit rates. So it's always, from a network perspective, by using multiple solutions, fiber, radio, free space photonics, then they can achieve a very, very high link availability, which is for the customers don't even notice what's happening in the back. So, yeah.
Big round of applause for Aircision.
Yeah, thank you.